All right, if you're a Java developer, you've probably faced this challenge. How do you get your front-end JavaScript to communicate smoothly with your back-end Java code? Well, today, we're going to pull back the curtain on a really powerful feature in the WebFirm framework that lets you create a direct, real-time communication line between your server and the browser.
So, this is the big question, right? Normally, you might think, okay, I need to set up some REST API endpoints, I've got to manage all these HTTP requests, parse JSON back and forth, and yeah, that works, but it's a ton of boilerplate. What if, and just imagine this, what if you could just call a Java method directly from your JavaScript, almost like it was a local function? That's exactly the problem we're going to solve.
And here is the solution, the custom server method. And honestly, it's pretty much what it sounds like. It's a bridge, a direct link that lets your client-side code call a specific piece of Java logic on your server, hand it some data, and get a response, all of it happening seamlessly and asynchronously. It is an incredibly slick way to build those really dynamic single-page apps.
So here's our game plan. We'll start by talking about this client-server bridge. Then we're going to roll up our sleeves and build out the server-side code, then jump over to the client side. After that, we'll look at how data actually moves between them, and we'll wrap it all up with the key takeaways.
I want you to think about this feature like you're setting up a private, direct phone line between a user's browser and your server. You're not just shouting across the wide-open field of random HTTP requests. Nope, you're opening a dedicated channel for a specific, ongoing conversation. This is really the foundation for any kind of real-time interaction.
Okay, so first things first. Let's start on the server side. This is where we define the endpoint of our phone line, the actual Java code that's going to be listening for that call from the browser.
On the server, pretty much everything starts with this one line of code. It's the add ServerMethod function. This is part of the browser page object, and it's how you register your Java method with the framework. You give it a unique name, kind of like a phone number, and then you pass in the actual logic to run. This is what puts it on the map so the client can find it.
Now let's look at a real example. So what we're doing here is defining a server method using a Java Lambda. This is awesome because server method is a functional interface, which means a Lambda is just a super clean and concise way to write out the logic. The event object you see there, that's our gateway to whatever the client sent us. We can pull data out of it, do some work, and then we build a new wffweb object to send right back. Finally, we register that whole block of logic under the name some unique method name.
Let's break this down even further. First, event.data is how you grab the package that just arrived from JavaScript. Next, we create a new wffbm object. Just think of this object as the framework's own universal translator. It's a special container that holds data in a way that both Java and JavaScript can understand. Third, we use the put method to load up our response package with whatever we want to send back. And finally, that return statement is what actually ships it back to the browser.
All right, our server-side code is set up, it's listening, it's waiting for the call. So, how do we actually make the call? Let's flip over to the browser side and see how to kick this whole thing off with JavaScript. And here it is, the JavaScript counterpart. The WFA sync.serverMethod function is your complete toolkit for making that call. You give it the exact same unique method name that we registered on the server. You pass an object with any data you want to send, and then you fire it off with .invoke. That invoke method takes one last thing, a callback function to handle whatever the server sends back.
And this code snippet shows you the whole process on the client side. We start by creating a simple JavaScript object called arguments. That's our getAPayload. Then we define a callback function. This function is going to run after the server responds, and it receives the server's data in its object parameter. This whole asynchronous thing is key, by the way. It means our web page doesn't freeze up while it's waiting for the server. It's non-blocking. Finally, we chain it all together. Call the method by its name, pass in our data, and tell it what to do when the response comes back.
So let's just make sure we've got this. First, that method name string, it absolutely has to match the name you define back in your Java code. Second, the arguments object is your payload. It can be super simple or really complex, whatever you need. Third, that .invoke call, that's the trigger. That's the go button that actually sends the request. And finally, the callback function is crucial. It's where you handle the data that comes back from the server.
So we've seen data go from the client to the server and back again. But what's really happening under the hood? I mean, how does a plain JavaScript object magically turn into a Java object? Well, this is where the framework really does some serious heavy lifting for you. This slide really shows off the magic of the automatic data conversion. When you send a standard JavaScript object from your client, it just arrives on your Java server, neatly packaged up as a wffbm object. The same thing happens in reverse. You return a wffbm object from your Java method, and poof, it materializes in your JavaScript callback as a standard, easy-to-use JavaScript object. It even handles binary data for you, converting between JavaScript's int array and the framework's wffbm byte array without you having to do a thing.
And believe it or not, it gets even more powerful. You are not just limited to sending strings and numbers. You can use bmValueType.function to send a complete executable JavaScript function from your Java server to the client. I mean, think about that for a second. You could send back custom validation logic on the fly, or a dynamic function to update your UI. That, combined with built-in support for binary data, opens the door for some incredibly rich and dynamic web applications.
Okay, we've covered the server, the client, and how data moves between them, so let's just zoom out for a moment and put all the pieces together and really talk about why this is such a game changer for building web apps with Java. When you boil it all down, the entire process is just these 4 simple steps. 1. You define your server logic. 2. You register it with a unique name. 3. You invoke it from your JavaScript. And 4. You process the results in a callback. It's a super clean, repeatable pattern for building out some really powerful interactive features. So, why does all this matter? Well, because it makes developing highly interactive applications way, way simpler. Think about things like live form validation, real-time data dashboards, or collaborative editing tools. Instead of building out a separate REST endpoint for every single tiny interaction, you just create a method. This means less boilerplate code, more of your logic stays together, and a much faster development cycle for any feature that needs that tight client-server communication. And that really brings us to the final thought I want to leave you with. Now that you see how to create this direct line between your client and your server, just think about the possibilities. How could this simplify data validation in your next project? Or how could you use it to update a UI in real time? It's a really powerful tool, and now it's in your toolkit. Thanks for joining us for this explainer.